So I am adding one more term, reasoning, to the word knowledge representation. So our topic of discussion for today will be knowledge representation and reasoning. In short, we will be calling it as Kr&R or Kr squared. So knowledge representation and reasoning represents information from the real world. This information has to be understood by the computer, and this knowledge which is received from this representation, knowledge representation or knowledge base, is used for solving complicated real life problems. And after that, it has to be communicated to human beings in natural language. It is not computer language because humans cannot understand computer language. So it has to be, or the problem has to be solved in terms of natural language. Knowledge representation represents knowledge such that it can facilitate drawing of conclusions from the knowledge. So this knowledge is used for making conclusions on real life problems. While representing the knowledge, several issues arise, and let us see them one by one. So representation of knowledge by people has differences or variance from one person to another. A knowledge represented by a person will be different from the same knowledge being represented by another person. We have to take into consideration of all these things while using machines, because it has to replace the human brains or human intelligence. So this is an issue while representing knowledge. The nature of knowledge and its representation. There are variations in the nature of knowledge. Let us see with an example. Suppose X is a person. Consider X as a person, and he or she is feeding a dog, and it can be represented using predicate logic as feeds within bracket as arguments X comma dog, meaning X is feeding a dog. Let us consider another statement which gives the meaning almost the same in natural language. X gives a bone to dog. So we have one more argument with this. Besides the person X and the dog, we have a bone to be accommodated. So this can be represented in the predicate logic as gives within bracket arguments X, dog, bone, meaning X is giving a bone to the dog. Now, are these statements equal? It depends, because giving food is feeding. We can say if we give food to a dog or an animal, it can be said as feeding only with additional information as give X comma food implies feed X. If we have this statement or declaration, then only we can say that the dog is being fed with something. So giving, making the same sense as feeding will only be validated with the statement give X comma food implies feed X. So such differences will make the knowledge representation very complicated. So it is another issue. Another one is we can make the representation scheme as specific or generic. For example, we can say X is a cat. X is an object which is a cat. It is a specific representation and can be represented in predicate logic as cat X, where X is the argument or attribute. Whereas we can have a generic statement like all cats have tail. It is not for a particular cat. All the cats are having tail. Let us assume like this. Then this can be represented using for all x, cat x implies tail x. For all the x, if x is a cat, then x is having tail. So these also have a difference in representation, specific taking a form, generic taking another form. The nature of representation or formal language has to be following the rules of the language, which is syntaxes and semantics. So the knowledge representation system or the system which is handling artificial intelligence problems should also handle our normal natural language. So it has to follow the rules of the language, which are the syntaxes and semantics of the language. Then we have seen declarative and procedural schemes, where declarative can be expressed in words. So there is no point in or problem in storing those points or those facts. But when we consider the procedural, which is action oriented and cannot be verbalized every time, then such information or facts cannot be stored in the system because it cannot be transferred from one person to another person. So it is not convertible to verbal form. Thus we cannot say store that thing into the knowledge base. So this is also an issue. We have to consider all these issues while generating an intelligent system with the aim of replacing the human brain. In addition to the problems discussed earlier, there are researches on the two or three topics which are spreading activation, which means theory of how the brain iterates through a network of associated ideas to retrieve specific information. In our brain, every object will be tied or linked to another object, and they will be related, and with these relations we will be retrieving specific information. Some of the objects will be closely related, whereas other objects will be loosely related. When the relations are very close, we can say that we are close to the information or concept. That is known as spreading activation. Again, it depends on the person who is using his or her brain. There may be variations from person to person. Another one is subsumption, which deals with a selective inheritance. When we are considering the attributes of objects, we can say that the objects can be inherited if they belong to similar classes. That means once we define something for an object, a similar object can be used or inherited from the previously defined object without redefining the new object. You might have seen this in object-oriented programming. So likewise, we can use selective inheritance. We may not have to consider all the properties or attributes which are being inherited, because some situations need only some part of the attributes. So in that case, we can use selective inheritance, discarding other attributes from that objects. That is known as subsumption. Another one is classification, which deals with classification of a product or an object under a group or a subgroup. We can group the project into a full group or a subgroup. Whenever we are going for subgroup, we can minimize the number of things to be searched for making decisions. So the knowledge in that case can be reduced, or the bulkness of the knowledge can be reduced. So these are also issues concerned with knowledge representation. Then some properties of knowledge representation. One is representational adequacy. It is the ability to represent all kinds of knowledge that are needed in that domain. Our representation should be adequate to cover all the needs in a domain where the problem is existing. That is known as representational adequacy. Another one is inferential adequacy. It is the ability to manipulate the representational structures and produce new knowledge. So we will be storing some information with some representation or format of representation. So some knowledge will be stored, and we have to manipulate that structure using which knowledges are stored. Then from these knowledges we have to produce new knowledge. Naturally, new knowledge will have new structures also. That is known as inferential adequacy. Then inferential efficiency. It is the ability to incorporate additional information into the knowledge structure, which can be used to make complex deductions. We have to make additional information. So the knowledge base is not static. It has to be updated and improved with additional knowledge. For that we will be using different structures, because already existing structure is for the existing knowledge. When new knowledge is coming in, we have to use additional structures, and using that we can build up the volume of the knowledge, and this can be used for making complex knowledges or complex conclusions, so that complicated problems can be taken into consideration. The final one is acquisition efficiency, which is the ability to acquire new knowledge using automatic methods wherever possible, rather than depending on human intervention. So the human being should not intervene into the process of acquiring new knowledge. It has to be generated from the existing knowledge using automated programs wherever possible. So the human being should not enter into the activity of generating new knowledge. That is known as acquisition efficiency. So these are the 4 properties of knowledge representation. Then let us continue with the issue with knowledge representation techniques. So this is an inheritable knowledge representation which uses is-a inheritance and instances of some entities. All these are attributes. Some attributes are important for deduction of some knowledges. This may be when we are considering one object or entity, we may have to consider more than one property or attributes associated with that object. So we have to make out which all things are important for the entity. That is an issue with knowledge representation. For example, important attributes. There may be two attributes. Sometimes it can exceed two also, as shown in the diagram, which used instances and is a relation. Since these attributes support property of inheritance, they are of prime importance. So whichever attributes are of importance to an entity or object, they have to be in demand while representing knowledges. So they have to be included in knowledge representation techniques. So the prime problem here is that we have to make out which all properties or attributes are important to some objects or entities. Then relationship among attributes. Basically, the attributes are used to describe objects, and these objects are entities. However, the attributes of an object do not depend on the encoded specific knowledge. Suppose there are different objects and they are having different attributes. They may not be depending on each other. So that is known as relationship among attributes. When we encode specific knowledge using these attributes, they may not be related. Then choosing the granularity of a representation. We know that granules are small particles of an object. They are known as granules. So while deciding the granularity of representation, it is necessary to know the following. So we are minimizing the size of something, and while minimizing we have to follow these the following conditions. What are the primitives and at what level should the knowledge be represented? We have to find out the level of knowledge representation. What should be the number? It can be small in number or large in number of low level primitives or high level facts. So up to what level we may have to divide something into its smaller form. So we are keeping something with a size, and we have to decide whether it should be small enough or large enough. That is known as granularity. High level facts, if you are going for the high level facts, it may be insufficient to draw the conclusion. If the facts are at high level, then it is not good for drawing conclusion. Then the other option is keeping the facts at low level with low level primitives. Then the number of facts will be more in number, which affects the storage. It requires lot of storage. Whenever we are having so many number of facts, we can have good decision, but it requires lot of storage space. But if we are keeping this very large, then the number of facts will be less in number. Then it may be insufficient to make out some conclusions. So we have to make some average between these two, and this is known as granularity.